Welcome. Today we have our math lesson and we want to have a quick review of our topic of indices. I want us to have a summary of the whole of that topic called indices. We write the most important areas, and then we see how they are applied. So the subject of today's lesson is called indices. So if you are having somewhere to write, please you can note this one down, indices. And I will go direct to the key areas that I want us to talk about. We know that indices, the definition of that, the other name for indices is also the power, which is very common, or even the logarithm. So this is another name for indices. And if I say 2 power 3, this is what we are saying is called the index of 2, and this one is what you're calling the base of this number. So the base of this number, if I say 2 power 3 equals to 8, or 8 is equals to 2 power 3. So this is what you're calling the index, or even in the indices, and the base, and this one is the number itself, and it's something that we've been doing so that you get to know that the power here, I want us to talk about this power, the index, or the power, or even the log. So we have these three names. They refer to the same thing. We have some of the laws that govern the power here. I'm going to highlight them. The laws of indices. The laws of indices. We have several laws. I'll just have a quick summary of them, but I want us to take some time in fractional indices. We see how they are applied. So the first law is called the multiplication law of indices. Multiplication law of indices. So this law, and is as short as this, just says that when you multiply two numbers with the same base, then you add their powers. When you multiply two numbers with the same base, then you add their powers. If I have, let's say, number A, maybe raised to power x, I'm multiplying by another number A raised to power y. The answer here is supposed to be A. If you multiply two numbers, the base here is A, the base here is A. So if you multiply two numbers with the same base, then what you do, you add their powers. So you add their powers like mine here. So this one is a law of multiplication of indices. That when I multiply two numbers with the same base, I multiply their powers. E.g., I can have a number like 3 power 2. I multiply by 3 power 3. This is the same as, after confirming that they have the same base. If they have the same base, base 3, this is the same as 3. You just take the power, you add them together. I take the power here, this power, I write here, and I add to this power. So that this is the same as taking 3. What is 2 plus 3? The answer here is 5. So this is the law of multiplication, and is the first law. The law number 2 is called division law of indices. Division law of indices. And this one simply is the opposite of this. So if we divide two numbers with the same base, instead of multiplying, if we divide two numbers with the same base, then we subtract their powers. So I'll have the same thing. If I take number A, I am raised to power x. Instead of multiplying, we are dividing with A raised to power y. This is simply the same as A. You take x, I am subtracting y. And this is the law that governs two numbers that are divided and are having the same base. so that if I have an example in this one, just pick the same example, I change whatever I'm having here, the same example, this one, I say 3 power 2 instead of multiplying, you divide because you're talking about division. I divide by 3, power 3. This one is the same as 3. You take 2, you minus 1. You take these 2, no, not minus 1, but you minus, sorry, you minus 3 here. So that the answer here will be the same as 2. If I take 2, the base here is 3. I write 3. Then I take 2 minus 1 is the same as negative 1. So this is how this law is applied. And remember, this number can also be written in this manner. 3 power 2, we are dividing by 3 power 3. This is the same thing. I'll just come here and say this is the same as 3. 2 minus 3 is the same as negative 1. So this is the law number 2. The law number 3, is the zero index. Is the zero index. The zero index is another law that governs the powers. And the summary of this is that any number raised to power 0, any number raised to power 0 is the same as 1. So if I pick a number like a raised to power 0, any number, a can be any number, is representing any number, is simply the same as 1. It doesn't matter what I am having, what type of a number I am having. Even if I have 761, as long as the power here is 0, this one is an example. As long as the power is 0, then this number is the same as 1. So any number can be expressed this way, but as long as the power is 0, then the number is 1. The law number 4 is the negative indices, the negative or the negative index, the negative index, the negative index. So this one again is a very important law in mathematics, the negative index, and simply is, I put a summary as this way. If I have a power x, this can also be written as, I write the reciprocal of this number, but I change the sign. The sign here is positive. So if I want to write as a negative index, I can just drop it down 1, the reciprocal. Remember here, a number, the denominator here is 1. So now that you're not writing, so it's the same as like that. The sign was positive, I change to be negative like that. It's also true when I say that, for example, a number raised to power negative x. This is simply the same as reciprocal again, 1 all over a power x. So you make sure that you change the sign. Everything else remain the same, except that it is a reciprocal of the other, and they mean their sign changes. So that is the negative index. I think I can have an example of a negative index, and I can pick a number. If I write 5 power 2, if I want to write as a negative index, this can be the same as 1 reciprocal all over 5. The power here was positive, so if I change that one, it will be negative 2 like that. So that is law number 4. The law number 5, is the power of powers. Power of powers. If I have power of powers, and the terms here, so don't really get concerned about the terms that I'm using here. Don't be concerned so much about the term. In math, rarely are you asked to state the laws of indices, but it will be indirect. You'll be told to just apply whatever we've learned. So this law is simply like this. If I have a number raised to power to power x, x, a number a raised to power x. Then outside here, I am having power y. This law states that if I'm having power x and power y outside, it's simply the same as you multiply x and y, so that it will give you x, y. So you multiply this on the power and the power. So the law looks like that. And if I pick a quick example here, e.g., I have a number like 6 power 2. All these, we are raising it to power 3. This is the same as 6. I take 2, I multiply by 3, so that the base remains there. 6, 2 multiplied by 3 is the same as 6. So we have that. So this one is the fifth law that you are having like that. Then I want also to go ahead. This is law number 6. Let me open another page here. I open another page and we go to the next law here. Let me rule my board like that. And the next law is called the law. Let me pick the other one here that I want us to have a quick review of that in an orderly way. So after talking the number 5, that was number 5, we go to number 6. I'll have this one as a fractional indices. Fractional indices. Let us look at this one, and simply this one means like this, that I can have a number written in this form. Maybe the power here, instead of being a whole number like what you've been dealing with, it can be a fraction. Let us say x all over y. So you can have something like that. And I think here I can go direct to an example here, of fractional indices. If I pick a number like 64, I'm raising this one to power a half. How should I solve this? Let me go backward a bit. I have this one in terms of the examples. So let me have example 1. I want to solve this one, Roman 1. I have 64 raised to power a half. 64 raised to power half. So for this one, I will come and get the factors of 64. I want to have the factors of 64. So the factors of 64, we know how to get it. If you can't remember, I simply apply these. I know by 2, this one is 32. By 2, this one is 16. By 2, this one is 8. I want to get the factors. By 2, this one is 4. Then you're having by 2, like that. But in other examples, I'll not be applying this one. I'll be going direct to getting the factors of a number. So 64 as in power form is the same as 2. 2 appears how many times? 1, 2, 3, 4, 5, 6. Is the same as 2 power 6. 2 power 6. Therefore, this 64 can also be written as 2 raised to power 6. As 2 raised to power 6. Therefore, I'll come and write where we have 64. I will write 2 power 6. Then the power that was outside this one is a half. Then I work out. Now I apply our previous law, the law of the power of powers. If you're having a number like this, you can multiply the powers. So I'll have 2. If I try to open the bracket there, it is 2 base 2. I write 6. I'm multiplying by that one. This is a normal sum. I work it separately. So please don't get confused. This one is a whole number. This is a fraction. If I work it here, it's like 6. I am multiplying 6. I am multiplying by a half. So this is the same as all over 1 there. So by this one, by 2, we are having 3. So that this number, whatever I'm having here, is the working here. By 2, 1, by 2, 3. So you can see whatever remains as the power here, it is 3. So this is the same as 2 power 3, which I can leave in terms of power form or in index form, or I can go ahead and interpret what is the meaning of this. This means that 2 you multiply by itself 3 times. This in power form, it means that 2 you multiply by itself 3 times, which is the same as 2 multiplied by 2 multiplied by 2, and my answer is 8. I can either leave my answer in this form or that, depending on the instruction. Let me pick Roman 2. What if you have an example like this one, a fraction like this one, a power whose fraction is of this form. So let me pick 729. We are raising to power 2 all over 3. Power 2 all over 3 to all over 3. How should I work out this one? I will do the same thing. I'll do the same thing. I'll try and get the same way I got the factors of 64, and I wrote this 64 in power form or in index form in this way. Is the same thing. I'll come here and do the same thing. And you realize if you work it out using the same method, you realize that 729 is the same as 3 power 6. Then all these we are raising to power 2 all over 3. I'm just following the same procedure like this one. Then I work out. This is the same as, if I try to open the bracket, this is the same as 3. You take a 6, we are multiplying by 2 all over 3. You can see by 3, 1, by 3, we are having 2. So our sum becomes like this. The power here remains to be 2 multiplied by 2, which is 4. 2 multiplied by 2 is 4. So the power here, base 3, the power is 4. I can leave my answer in this form, or I can go ahead and ask myself, what does 3 power 4 means? And I think this is 3 multiplied by 3 multiplied by 3 and multiplied by 3 4 times, and my answer is supposed to be 81. Although, depending on the instruction, I can leave my answer this way, or I go ahead and work it out. So this is my answer. This was our answer. I want to present the last example of fractional indices and see how the sum looks like. I have a number. Let me pick a number that is fraction. Instead of having this, let me pick a number that is somehow a fraction. So I have an example 3 or Roman 3. I have a number like 625. We are dividing by 16. We are dividing by 16. Then all this is raised to power 3 all over 2. Is raised to power 3 all over 2. I will do the same thing. I'll come here and interpret, get the factors of 625, write it in power form. What is 625 in power form? If you work it out, you'll realize that this is the same as 5 power 4. And what is 16 in power form? 16 in power form is the same as 2 raised to power 4. Then all this, remember I've just written this one in another way. This is the same number. This 5 power 4 is 625. 2 power 4 is 16. So I want to still include this one. I put it outside. Like that. So whatever you're having outside, it was 3 all over 2. Then I go ahead. Now, for this one, you are having all these number, both the numerator and denominator, their power is this one. This 3 all over 2 is not a power of the numerator alone and not denominator alone. It is a power of both numerator and denominator. And for that reason, I cannot just multiply this power 4 multiplied by 3 all over 2 and leave this one behind. Every number here needs to be multiplied. So I will come here and do this. I'll take 5 power 4, this number. I am multiplying by 3 all over 2. Then also 2 power 4, I am multiplying by the same power because I am opening bracket. I am opening the bracket. Just a reminder of how we normally open the bracket. If, for example, just something away here, if you have 3, then inside the bracket you have x plus y. How do you open this bracket? We normally you take this one, multiply by that, and the same number you multiply by that. So I am applying this scenario here because this 3 opens the bracket of is multiplied by x and also y. You don't multiply by one number alone. So the same case, because this power is a power of both the numerator and denominator. So I have to multiply the two of them. And if I work it out, so what will be our answer here? By 2, 1, by 2, I'll have 2. By 2, I can have 1. By 2, I'll have 2 here. And my answer will be 5. What do you remain with in the numerator? 2 multiplied by 3, my answer is 6. Sorry, let me write it well. The numerator here, we are having 5. It is what remains here is 2 multiplied by 3, which is 6, and all over 2. Then 2. This is 2. This 2 is for this base. Then 2 multiplied by 3, which is 6. So I go ahead. If I'm told to leave my answer in index form, I can just write that way. Or because these powers are the same, I can put them under the same power. So I put them 5 all over 2, all these raised to power 6. I can leave my sum like that. I can leave my sum like that. So this is what you can try to work it out. If you need to open the bracket, if remember, if this power are different, I cannot factor out. I cannot remove 6 outside. This is 6, this is 6. That is why I am taking it outside and remaining with 5 power 1. I don't write, if it's power 1, I just leave it because 5 appear ones, 2 appear ones, like that. So that is what we have for this one. I can leave my answer in this form. It is a better off. Is a simplified way if I want to leave my answer in power form. So that is what you are having. This is the laws. So I would wish to get to hear what you have to say. And I can leave one sum. Maybe I write it as an exercise here for you to attempt. An exercise here for you to attempt. And let me see your answer. What is your answer after solving this sum? You tell me what will be your answer when you solve this sum. I'll just give one. 243. 243. I am dividing by 32. Then all this, I am raising it to power 3 all over 5. 3 all over 5. So this is the power. Please, I would wish to get your answer in the comment section. You can work it somewhere and let me know what is your answer. All the steps, of course, you indicate all the steps. I hope you've enjoyed the lesson. Please feel free to check it and give me your feedback. I will really appreciate your feedback from this. Thank you so much. like and also you subscribe to our channel for more sharing of mathematics and sciences, especially physics. Thank you.